Hello. Hi, guys. My name is Austin Cottle. I am a success coach here at Hazard Community and Technical College. Math is kind of my jam, it's what my degree is in. So, while I can help you with advising, registration, resources that the college has to offer in house or maybe in the community, I'm also a great support for mathematics and I would be happy to help. And today I'm here to help you learn Chapter 3.2 to 3.3 in your college algebra class. Alright, so let's begin with numbers 1 and 2. You have a set of ordered pairs here. The brace indicates to me that that is set notation. So that tells me you just have a big list of ordered pairs, right? And every ordered pair is x comma y. And that means when you're on the coordinate plane, I'm sure you've seen the coordinate plane quite a few times at this point. It's kind of like directions. It's like a coordinate plane is a map, and these are your instructions. So if I said I'm looking at point 1 comma 2, and let's just put some tick marks on here so we can map something on our map, aka coordinate plane. X is a 1 value, and that would be here because it's like the number line. This is positive x to the right, negative x to the left. So x would be positive 1, y would be positive 2, and y, if you go up is positive, down is negative. So 1, 2 would be this point, right? It's like instructions. So when I look at this in set notation with all of these ordered pairs, kind of weird because it's got some variables for the y coordinate, right? But that's okay. We're just listing the domain and range. Domain is a fancy way, that's what the D is for here. Domain is a fancy way of saying x values. So we're looking at all of our possible x values here. And like I said just a moment ago, ordered pairs are x comma y. So if we're listing all of our x values, that's going to be everything that is listed first in each individual set of parentheses. Right? So my domain is going to be 1, 2, 3, 4, and 5. And we would separate that with commas. And that would be my domain. And the R here, let me change colors. The R is for range. And that is a fancy way to say all of your possible Y values. So your Y values are S, D, J, C, and M. So we will list those and we will separate with a comma. S, D, that D went a little sideways. J, C, and M. If that makes sense. Domain is your X, first thing in the parentheses. Y is your range, second value in each parentheses. So, got it for domain and range.
The only thing extra is if not provided, you have to put the little curly braces. If they're
Okay,
not provided
yes.
for you.
I agree with that. Good point. I almost didn't say that. So, if you're making a set, like a set of values, you put it in set notation by surrounding it with a brace on each side. You're saying a brace, not a parenthesis, correct?
Right.
Okay. Yay.
And I'm glad you mentioned that.
Yeah.
Parentheses are used when it goes from a specific point to another specific point and includes everything in the middle. Curly braces are used so like everything from 1 all the way to 2. Like this. Um, Parentheses are also used when putting ordered pairs.
Right.
Curly braces are used when you're doing individual points.
Mm-hmm. Good to know. Thank you. All right, so how do you know if a set is a function? Here we have the ordered pairs 2, 4, 3, 7, 2, 8, and 6, 9. And this is always the rule that I kind of go by. It's written a little bit differently in the text. It's kind of worded confusingly, in my opinion, because it always says there is one specific X for every assigned Y, or something along those lines. And I'm always like, oh, it's so hard to understand what they're saying. So I always just say you cannot repeat X. You can repeat Y all day long. But not X. Okay, so when I have the same X value listed more than once, for example, I have 2 here and I have 2 here, I have 2 ordered pairs listing 2 as X. That's not a function. You cannot repeat X. But down here for C, we have another set of ordered pairs. And I see the X values are 2, 3, 4, and 5. Can't repeat X. It is a function. You can repeat Y all day long, like I said. This is still a function. They use 3 multiple times. That's okay to do. You just cannot repeat any X value. So this is not a function for part B. This is a function for part C. If that makes sense.
Okay, hang on, don't clean it. A real life example of this, okay, would be if I have a chocolate chip recipe, a chocolate chip cookie recipe, and I got a chocolate chip and a snickerdoodle without changing the recipe. Is that physically possible? No. Can I have 1,000 different chocolate chip recipes and still get a chocolate chip cookie? Yes.
Yeah, good example.
Yes.
I didn't think of that. I know a real world example for this too. You can say like X is different people, and then Y is their birthday.
Mm.
And then,
Mm-hmm.
Lewis and Philip can have the same birthday. Well, that would actually be here. Like, Lewis and Philip can have the same birthday. But you can't have Lewis having 2 different birthdays.
Right.
Yeah.
Good job.
That's one that I like to use. I like the cookie one too. All right, so number 3, we're going to get the domain and the range and notate if it's a function or not from the graph. This U shape, it is called a parabola. Really fancy way of saying this is a graph for a parent function that's like x squared. And domain, we want to list all of our possible x values. And if we look at this parabola, it looks like there's a lot of different x values. We've got -2, we've got -1, we've got all the values in between, we've got 2, we've got 3, because that kind of falls on the parabola as well, and we've got everything in between there too. This graph, it doesn't totally show this, but it continues to go on in both directions. And if you go on forever and ever and ever in this direction, that's positive infinity. If you count all the way you can positive, that'd be positive forever. It'd be positive infinity. And we say infinity with this symbol. If we go to the left, it's like going to the left on the number line. You go negative on and on and on until you get to negative infinity, which is notated like this. And your domain is just all of your possible x values. And if I'm going forever and ever to the right, forever and ever to the left, my domain is just going to be negative infinity to positive infinity. And I'm including everything in there. And we have to use a parenthesis because we can't define infinity. Like, we know it goes on forever, but we don't know what that value is. So whenever you use infinity at all, you have to use a parenthesis. If you are talking about range, for example, that's going to be your y values, all possible y values on the graph.
And it goes from bottom to top.
Yes, because it's a parabola pointing upward. So this is your very lowest point, and it continues towards positive infinity. So you're going to start at the y value for the minimum, which is negative 8, and we're going to use a bracket for that because we include that value. And we go on to positive infinity, and that is with a parenthesis because we can't define it. But range, you always use this bracket when you're talking about your starting value that you use on the y-axis or in the y value. Does that make sense?
Yes.
Okay.
Now, if it starts at negative infinity and it has an ending point, then y'all use the bracket at the ending point. So if it's upside down,
Right.
yes.
That would change the game for
Yes.
sure. So let's say this was a y value. Let's just say the point is like negative 2, negative 2. Or sorry, negative 2, positive 2. And your y value on this maximum, because it's an upside down parabola, is 2. So you're coming up from negative infinity, and your maximum is 2. So you would notate that as negative infinity as your starting point, and you come all the way up to positive 2. Right.
Good.
Okay. Does that make sense? I hope so.
Yay.
If not, ask Miss April for sure. We'll be able to answer your questions. Miss April is the guru. All right, so choose the correct graph for x equals y squared.
On that one, make sure to use Desmos.
Yes.
So that a lot of people get this wrong because they're looking at y equals x squared
Mhm.
and not x equals y squared. So make sure to type that into Desmos.
Mhm.
And I put one that was, they can't see the Desmos. They can't see the Desmos.
Oh, okay.
Yeah.
Yeah.
That's why.
I thought if I went over here and clicked share this tab, it would work.
Oh, I don't know.
Let's try it. So y squared.
Click content and see. They can. Oh my goodness, I just learned something new. Yay!
I get to teach you something for once.
Yay! So the one I've got up there right now, she just typed that one in. So,
Yes.
um,
And we can zoom out. We
yes.
can zoom in.
Now type x equals y squared. So that way you can see what both of them look like.
Mhm.
Now, kill the top one.
This one?
Yeah. Now hit enter. Type in y equals x squared.
Mhm.
That's what most students mess up.
That this is the
They
inverse.
think the blue one is what they're supposed to be doing.
Right. The blue one is traditional, like quadratic
Right,
or x squared parent function.
right.
And then this, when you flip flop x and y, is the inverse. And a lot of inverse functions you'll notice because they're rotating them like 90 degrees to the right. They're just kind of rotating them
Right.
just a little bit to the right.
Yes.
So same sort of shape, but that's how I knew it was inverse. And that's how I kind of realized it was y equals x squared
Yeah.
right off the bat.
So,
Or x equals y squared because it was flip flopped.
yeah. So,
Yeah.
number next.
Awesome.
By the way, the domain on this one is interesting.
Mm-hmm.
Show them the domain on that one.
So for the domain, all of your possible x values, it kind of looks like it goes on and on and on in both directions, and that's great. It's gonna probably reach negative infinity on the left, but it kind of caps out at 0 here, and it
Yes.
doesn't go past 0. So it'd be negative infinity to 0.
And it would have a parenthesis and then end with a bracket.
Yes, because we are including that value.
Yes. And then your range would be negative infinity to positive infinity because it goes down forever and up forever.
Yeah, those inverse functions have different domains and ranges.
Yes.
But as long as you kind of follow how far can it go, what's the max, what's the min, as far as x values, as far as y values, and you follow the pattern of the graph, should be good.
Yes.
And any questions, here to help. Miss
Yep.
April will answer.
Page next.
Yay. Zoom in. All right, so number 5 is more of an application problem. It's like a real world problem. Those can be a little more challenging. So we're going to go over a couple of those. And number 5 says you have a long straight river. It's 100 meters wide. It's flowing at 1 meter per second. A pollutant is entering the river at a constant rate from one of its banks. As the pollutant disperses in the water, it forms a plume that is modeled by this equation, y equals square root of x. Use this information to answer the following questions. And we do have this visual for us, which is really nice. We've got this kind of right triangle. And we've got kind of the square root x, which is part of the equation. And then we have the y as the side. That's cool. And then
And
x,
right down here is
x
x.
is the base. It cut it off a little bit, but I thought
Yeah.
so. So yay. All right, so how wide is the plume 144 meters downriver from the source of the pollution? So this would be your input, and you would use that for your x value because when you're working in equations, x is your input that you plug in, and then you use the order of operations, you calculate, y is the output. Okay, just making sure we're still good. Technical checking. All right, so we're going to go and plug 144 in. So y equals square root 144. And we can totally put that in the calculator. If you don't recognize